Welcome to watch the video of code converters. So code converters, there are several types of code converters. So what is the use of this code converters? So when you are using a code converter, that circuit enables the two systems to communicate despite the fact they can employ distinct binary codes. Okay, so there are several types of codes are binary code, gray code, BCD code, Excess-3 code, okay, 7-segment code. There are various types of codes. So this is a type of a binary to gray code converter table. So the combinations from 000, 0001 up to 1111. Okay, for this, how the output has been drawn. Okay, let us discuss G3, G2, G1, G0. G3, how G3 is calculated. So G3 that is equal to B3. Okay, then G2, how G2 is calculated. G2 has been calculated with the help of equation B3 exclusive of B2. Okay, we are using XOR gate. So 0, 0, 0. So 0, 0, 0. 0, 0, 0. So here it is 0, 1. 0, 1 is 1. Okay, so 1, 0. That is also 1. 1, 1, 0. When both the inputs are same means it is 0. When it is one input is 0 and another one is 1 means we are getting the output. That is the concept of the XOR gate. Okay, then G1. How we are calculating G1? B2 exclusive with B1. Okay, then finally G0. B1 exclusive with B0. Okay, three output values we plotting the K-map. For G3, G2, G1, G0, we should plot the K-map. Here it is B3, B2, it is B1, B0. So here we can group all the ones in these 8 cells. It is for G2, G1, it is for G0. You can get the equation. So after getting that, we should draw the logic diagram. G3, that is B3, G2 is B3 exclusive of B2, G1 is B2 exclusive of B1, G1 is B2 exclusive of B1, then G0 is B1 exclusive of B0. Okay, so by using the XOR gate, grade 2 binary code conversion now. Okay, so here now this gray that becomes the input and the binary code that becomes the output. Okay, so it starts from 0, 0, 0. Okay, then the same combinations has been used. Binary code is the output here. So B3, B2, B1 and B0. Okay, so how B3 has been calculated? B3 has been calculated with the help of G3. B3 equal to G3. Then now B2. B2 has been calculated with the G3 exclusive of G2. Then B1. B1 has been calculated with the equation of G3 exclusive with G2, G2 exclusive with G1. Okay, then finally B0. B0 has been calculated with the exclusive of all the 4 inputs. Okay, so G3 exclusive with G2, G2 exclusive with G1, finally with G0. Okay, so how we are finding the exclusive operations? We already know that parity bit combination. Whenever we are calculating the number of ones or even means, we should put 0. When the number of ones are odd means, we should include 1. Okay, that is similar to that of XOR gate. Okay, so B3 has been calculated with the G3. Now B2. So G3 exclusive with the G2. Okay, so 0, 1 means that 1. Okay, when the number of ones are odd means here we are getting 1. Okay, when the number of ones are even means we are getting 0. That is also similar to that of XOR gate. So for B1, we should check with all 3 combinations. Okay, so here we are combining 0, 1, 1. So the number of ones are even. So it is 0. Okay, similarly for B0, the same combinations. So you should calculate the number of ones. Whenever it is odd means you should put a 1 here. Here you can see for B0, calculating B0, all 4 are exclusive. So here the number of ones are even. So it is 0. So here the number of ones are odd. So we should add. Likewise, we should draw this. After plotting the truth table, we should draw the K-map for all the outputs B3, B2, B1 and B0. Okay, now we get the equation. After finding the equations, we should plot the logic diagram for B0, that is all exclusive. Then B1, G3, G2, G1. For B2, it is G3 with the G2. Finally, for B3, it is G3. BCD to Excess-3 converters. So BCD normally that starts from 0 and ends at 9. So 0 to 9 means automatically it comes under the 4 variable. Okay. Excess-3, excessing 3, which means whenever the input is 0 means output is 3. Okay, so here you can see 0, 0, 0, 0. So the output is 0, 0, 1, 1. Corresponding decimal value 3. So for 0, it is 3. For 1, so 1 plus 3 is 4. What is the corresponding binary value for 4? 0, 1, 0, 0. Okay, when the input is 2 means corresponding output is 5. Okay, so 0, 1, 0, 1. Okay, similarly for 1, 0, 0, 1, it is 12. For 9, it is 12. So 1, 1, 0, 0. For the combinations, the 10 to 15, there will be no output. So it should be considered as a don't care values because BCD is from 0 to 9 only. From 10 to 15, there will be no values. Outputs, we are calculating the equation with the help of K-map. So B3, B2 here, B1, B0. B2, B3 and E0. Okay, outputs. So for that output, we draw the logic diagram. So this is a diagram for the BCD to Excess-3 code converters. Then similarly, Excess-3 to BCD. Okay, the reverse process. So the output comes in the input side, input comes in the output side, having that B0, B1, B2, B3 as the outputs. Okay, so for that truth table, we should draw. So X1, X2, X3, X4 or E1, E2, E3, E4 are the inputs here. Okay, the reverse process. So after finding the simplified expressions with the help of K-map, we should plot the logic diagram. X1, X2, X3, X4, the inputs with the outputs. We can represent it by A, B, C and D. This is the binary coded decimal conversion.